Good day, my name is Ewing, and this video will be about my Mastermind assignment for the course CSC1024 Programming Principles. For CSC1024, the programming project assigned was to develop a video game version of the original board game Mastermind. Traditionally, Mastermind is a two-player game where one player will act as the codebreaker and the other as the codemaster. The goal of Mastermind is for the codebreaker to guess the codemaster's winning color sequence within 12 tries, as there are only 12 rows on the board. The codemaster will be the player who decides what the winning color sequence will be, while the codebreaker will be the player who tries to decipher the winning color sequence in 12 tries by placing 4 colored packs onto the board every round. At the end of each round, the codemaster will provide feedback using 2 unique packs which have either of the following meanings. A white pack to represent that a correct color is found but just in the incorrect position, and a black pack will have the meaning that a correct color has been found in the correct position. In the board game version, if the codebreaker fails to guess the winning code within 12 tries, they lose the game and the 2 players switch. If the codebreaker guesses the winning code in 12 tries, the 2 players switch, and the codebreaker that guesses the winning code with the least number of tries wins the game. Before demonstrating the program, I want to lay out some differences between the board game and the computer game version. In the computer game version of Mastermind, the computer will act as the codemaster while the player will act as the codebreaker. Most of the rules will remain the same in the computer game version, with the rules such as the codebreaker having only 12 tries to correctly guess the winning color sequence. Feedback will be provided after every round when the codebreaker enters their guess using the following 2 messages. Correct color but in the incorrect position to represent the white pack. Correct color in the correct position to represent the black pack of the original board game. And a number will be displayed after the messages to inform the codebreaker/player how many colors they got in the incorrect or correct position. There will be no switching of players, as the computer will act as the codemaster, and therefore, if the player is able to guess the winning sequence within 12 tries, they win the game. Otherwise, they lose the game. When the game first runs, the player will be brought to the start screen as seen here. The player will be prompted to enter an integer input to select the function they want to use. Entering an unaccepted input here will result in an error message appearing, informing the user to enter an accepted input once again. The error message will display that the user has to select either one of the options displayed on screen. Entering 2 will print the rule screen. While entering 3 will exit the game. And entering 1 will start the game. In the rules screen, the rules and how to play Mastermind will be displayed to teach newcomers how to play the game. Once the user has understood how to play Mastermind, they can input an integer once again in the start screen to play the game. Upon exiting the game, a message will be printed to thank the player for playing the game. To aid users in playing the game, a board will be printed out for every of the 12 rounds, displaying the colors the player selected for each round. Beneath the board will always be a legend displayed for the player to know what colors they can input. Entering a color that is unavailable will result in an error message appearing, informing the player to enter an accepted color as displayed in the legend. Entering more than one character in this case will also result in an error message, informing the player to input only one character. To reduce confusion when entering input, the program will ask the player to input each color according to the column stated in the input message. For example, enter one letter, uppercase or lowercase, from the legend to enter a color into column 1 will inform the player that the color they input in this section will be put in column 1 of the board. After every round, a result screen will appear, displaying the number of correct colors in the correct positions and the number of correct colors but in the incorrect positions the player got just beneath the board. The player will continue to input 4 colors until all 12 rows of the board have been used up, indicating that all 12 tries the player has have been used up. As stated before, if the player is unable to guess the winning code within 12 tries, they lose the game, and a message will appear to wish the player a better luck next time, as well as display the winning sequence. If the player is able to guess the winning sequence within 12 tries, then they win the game, and a congratulatory message will appear to congratulate them and display the number of guesses they took to win the game. After either a congratulatory message or a better luck next time message is displayed, the user would then be brought back to the start screen and they can choose to exit the program or play the game again. To aid users/players to play the game, when the program starts, the user or player will be brought to the start screen displaying all the options the player can choose from. The function of each option will be displayed next to the option's integer code, and the player will be asked to input an integer to select their desired function. Appropriate and informative messages will be displayed when asking an input from the player to further reduce confusion when playing the game. Input messages will inform the player to input an accepted input, while error messages will always be displayed for all inputs when the player enters an option that is not accepted, and the program will keep requesting for another input until an accepted input is met. In the computer game version, a board will be printed out every round to inform the player of their previous round's 4-color input/selection. A legend will be printed beneath the board to inform the player what their color options are. In addition, the board will have 2 labels, row and column numbers. A results screen will be printed after every round to provide the player feedback regarding their color selection. The labels on the board serve as identification mechanisms so that when the results are printed every round, the player will know which row and column to look at to figure out the next move. Lists are very useful tools when it comes to managing a numerous number of data and multiple data types. For example, if we have 6 integer data that need storing and accessing, instead of creating 6 different variables to store all of the integers, a list can be used to store and access all 6 integers anytime in a program. Moreover, lists can store different data types in one list, so in problems where multiple data of different types need storing and accessing, lists will be more useful than variable as the code will be shorter and more organized when handling numerous numbers of data. In the Mastermind computer game, lists were used for the following purposes: to store the 4 winning colors that the computer can use to randomize the winning sequence, to store all 12 guesses of the player in each of the 12 rounds, to store the randomized winning color sequence of 4 elements. To generate a winning sequence, the Python module random was imported and the random.choice function was used. A list containing the 4 possible colors the game can choose was created, and the random function utilized pulled its option from there using the syntax random.choice open bracket color underscore choice close bracket, where color underscore choice is the list containing all possible colors the player and computer can choose from. Randomization is helpful in cases such as the OTP, or better known as one-time PIN numbers, used in the financial sector such as banking, insurance, and more, where the transmission of sensitive data requires randomized confirmation codes for utmost security so that hackers are unable to predict the OTP codes. Other computational problems where randomization can prove to be helpful are in trivial cases such as deciding a winning code for a game and helping users decide what to do. Randomization is useful in problems where use values need to be randomized either for security measures such as generating a cipher code for encrypting data or deciphering messages, or just leaving it up to luck to decide what to do. Decision making generally refers to going through an information and making a selection for a certain action. In the Mastermind computer game, a countless number of decision making are utilized in order to decide the following few examples: whether or not the player has a correct color in the correct or incorrect position, what functions to run according to what parameters and conditions, whether the player has won the game or not, whether the player has input an accepted or unaccepted input, when to display error messages, what to do when an unaccepted input has been given by the player, what to display in what order, and how to display the player's inputs, whether to display a letter when there is an input or to display just a blank space when there is no input. Without decision making, the game will not be able to decide when the player has won the game, if the player has an input that is accepted or not, what to do when an unaccepted input has been provided, what function to perform, and so on. As we can see, there are countless number of decision making that are needed in order for the Mastermind game to run, and more can be seen in the code. Almost all programs cannot run without decision making, as it is a crucial logic question in deciding which action to perform given certain parameters and conditions. Common uses for decision making in computation communication problems are such as what to do when a user inputs an unaccepted input, what to display given certain conditions, and what to do when certain buttons are pressed or certain inputs are given. Without decision making, no program will be able to behave in the way programmers intend them to behave and will result in unusable programs. Iterative processes were applied in the Mastermind computer game to do the following. Run the whole program using a while loop, repeatedly ask user for an input until an accepted input has been given in the case of an unaccepted input, collect 4 inputs from the user without using 4 different input variables and appending them in the correct order in the player's set list that stores all 12 guesses of the player, and checking each input color of the user that is stored in the player set list with the winning sequence in order to determine if the player has won or lost the game and how many colors they got in the correct and incorrect positions. Iterative processes in the Mastermind computer game help keep the code much cleaner, as scenarios such as checking whether the player has a correct color in the incorrect or correct position, continuously ask the user for inputs when incorrect ones have been given, and collecting 4 individual colors to append in the correct position of the player's set list are processes that, whenever each process is executed, always have the same logic. Therefore, using multiple lines of similar syntax codes to execute each same process will make the code much messier for no rational or efficient reason. Iterative processes are useful in computational problems where problems that have the same or similar logic need repetitive execution, and so instead of creating multiple lines of similar codes to execute the same logic function, an iterative process will be much more efficient for the computer to execute. Many user-defined functions were used in my Mastermind computer game. All of the user-defined functions I made and used are as follows: start screen, rule screen, error message, result messages, check color, and print board. The start screen function is used to print the start screen that the user sees when they first run the game. The rule screen function prints the rules and how to play texts when invoked by selecting the option 2 at the start screen. Error message prints the appropriate error messages according to what error the user made during input. The function result messages prints out the feedback messages as well as a congratulatory message or better luck next time message depending on the outcome of the game. The check color function checks the player's latest guess with the winning sequence by taking in the player's list, the guess number, and the winning sequence. The function passes the result to the result messages function to decide which message to print out and what feedback to give to the player. Last but not least, the print board function prints out the board that displays all the 12 guesses of the player. Using these sub-programs in the Mastermind computer game, better known as functions, bring about a number of advantages. The main advantage of using sub-programs such as functions is that codes are more organized since each specific background operation, like checking the colors and printing the board in Mastermind, are kept inside an easily identifiable function instead of mixed together inside the main code. Both checking the colors and printing the board contain numerous lines of codes that run through many decision making to select what to do, and as such, keeping them in their own sub-programs makes the main code more organized, easy to manage, and efficient to fix problems when the program did not check colors as intended or when printing the board had issues. Overall, this means that troubleshooting issues and fixing them is much easier when sub-programs are implemented than when the codes for sub-programs are mixed into the main code. To conclude this video presentation, I'll give some afterthought regarding my experience with the project. I feel that if I was able to learn and utilize more complex functions from the Python library, I may have been able to automate certain things such as moving on to the next input automatically when one accepted character has been input by the player. Being able to utilize GUI elements in Python will have definitely helped in making a program that looks and feels more modern and enjoyable to use. Overall, I am satisfied with my end result, and it was a fun experience to code a Mastermind video game that actually functions as intended and is very close to replicating the original board game just in a computer game version.